All right, this is Ms. Haney. Hopefully you got a chance to practice figuring out the different key features of this graph. But I'm just going to go over it, so if you want to check your work, you can go ahead and do so. All right, so remember the first thing that we want to try to identify are going to be our x and our y intercepts. It looks like this graph only has two x-intercepts, one right here and the other right here. So we'll say that that is at 4, 0, and then there's another one at, looks like it might be 6.5, 0. All right, the next thing we want to look for is a y-intercept. This graph definitely does have a y-intercept. It is right here. And so we would say that point, looks like it's about 7.5. Now I'm not too concerned about the half, so if you said that looked like it was closer to 7, or you said it was closer to 8, you know, that's okay. We just want to make sure that you're looking at the correct part of the graph. All right, the next thing that we want to identify are the maximums and minimums. So we'll do maximums first. Remember, that's the top of any roller coaster hill. So this is not going to be a maximum over here because it keeps going up forever. So I'll never be able to find the top of it. So this is a maximum right here, top of a roller coaster hill. And that looks like it's about it. So I'm going to say that point is -1, +8 would be my maximum. All right, then we want to find minimums. Remember, those are the bottom of our roller coaster hills. So I have one right here, and I have one right here. So this looks to me, there's -5. It's a little past there. So maybe -5.5. And it is about 1 high, we'll say. And then I have another one over here at, let's see, 5.5, and we'll call that -3. Again, I'm not too concerned about you getting exactly the decimal. If you want to round a little bit, that's okay. So next we want to think about increasing, decreasing, and constant. So again, my suggestion is shrink yourself down, Honey, I Shrunk the Kid size, and put yourself on your graph. What are you doing if you walk along the line? Well, we're walking down. That means we must be decreasing. Since I've got negative numbers over here and an arrow, that means it must have been decreasing forever from the left. So that's what we're going to say. It's decreasing from -infinity, and it's decreasing, decreasing, decreasing until I get to this value. So draw your line down so you can see where it is. And it looks like it's about 5.5, -5.5. Okay, so from here, what's your little person doing? Well, he's walking up now. So I'd be walking up from this value of -5.5 until we get to this point right here, which looks like it's at -1. Again, we're only concerned with the x values when we're talking about increasing, decreasing, and constant. All right, from there, our little person is now walking down again, so I'm going to reuse that second number. Starting at -1, it's decreasing until we get here, and that value and the x-axis looks like it's about 5.5. And then what happens from here? Well, it starts going up again. Does it ever stop increasing? No. So it's increasing from 5.5 on to infinity. Constant, you want to ask yourself, is there any place where it's perfectly flat horizontally? And I don't see any on this graph, so I'm just going to say none. Symmetry, remember, if we can fold our graph in half, that would make it symmetrical. I don't see that happening here, so I'll say none. And then end behavior, my favorite, is what's happening as you go more and more negative and more positive in the x value. What happens to your function? So I start it as x approaches, we'll go to the right first. As x goes towards positive infinity, which direction is my function going? It's going up. So my function must be approaching positive infinity. If I go to the left, as x gets more and more negative, Where is my function pointing? It's pointing up. So up must also be positive infinity. All right, I hope you did an awesome job with that. And remember, if you have any questions, don't hesitate to ask me in class.